these are my 4 plates from last time. So I'll have a plasmid. It's called P no name. This is my own mammalian expression vector that I'm gonna use hopefully for my gene therapy project. The other one is called P3X. I'll have another one which is PUC. This is a modified version of PUC that I engineered and removed the BSA1 restriction site from. And this is also a modified version of pcDNA 3.1, again without the BSA1 restriction site. So if you can see, there is no growth on the negative control, and there's growth on the positive control. So that means that the plasmid I inserted into my bacteria provides resistance to ampicillin. So this tells me a lot. This tells me that the plasmid is present. However, how do I know if my plasmid is really there, or to be more specific, if the plasmid I wanted to insert is there? Because I don't know, it could be any other plasmid. Maybe I mixed up the tubes and stuff like that. So I'll need to further verify this, and I'm gonna do this by screening, in which I'm gonna use diagnostic restriction digest. So this is a way for me to screen for my mutant colonies prior to sequencing, because I'm not gonna sequence all of this here, right? So what I'm gonna do is the following. I'm gonna set up a restriction digest in the following way. This is a gel simulation, and this is Snappgene. So the program is called Snappgene. I'll leave a link in the description below on Snappgene Viewer. You can use it. I'm using this program to make, the designs for my cloning PCRs and so on. So first of all, I have the pcDNA plasmid. This is the wild type plasmid, which I'm gonna cut with BSA1. And I'm gonna go get 2 bands here. One that migrates around 4,000 and one that migrates between the 1.5 and 2,000 KB mark right here. So this is the non-mutated version of pcDNA. Second lane is my pcDNA, so the one that I modified, and I removed a BSA1 restriction site from. So if I cut with BSA1, instead of getting 2 fragments, because remember, BSA1 cuts, let me show you. So BSA1 cuts here, okay, and BSA1 cuts here. So if I get 1 cut here and 1 cut here, I'll have 2 fragments. And this will tell me that, the plasmid that I wanted to insert, my plasmid is the right one. This won't tell me for sure, but however, the chances are pretty high that that I got the right plasmid here. So here in my second lane, the mutated BSA1, the restriction enzyme BSA1 cuts in just 1 site, so I'll get just 1 fragment, which should migrate about between the 6,000 and the 5,000 KB mark, because it has 5,428 base pairs, right? It linearizes the plasmid. The same with my lane 3 is gonna be my plasmid, P no name. Lane 4, for example, is gonna be P3X. Again, I'm gonna cut with BSA1, and I'm gonna watch for the restriction pattern. And number 5 is gonna be the PUC18 minus BSA1 plasmid, so a modification that I made. Basically, I removed the BSA1 site from the plasmid, so BSA1 will not cut, so I'll get, instead of the linearized form like here, I'll get the supercoiled form. Basically, I'm gonna get all 3 plasmids form, with this, whether it is nicked, circular, or or whatever. Okay, so let's get to it. I'm gonna show you exactly how I'm gonna do my screening and my diagnostic digest. Okay, so now I'll be writing the tubes. I should have a control for PAC, but sadly I don't have DNA for PAC 18. Okay, so in each tube right now I have some PCR water here. I need to thaw a bit. In here I'll have, this is the pcDNA plasmid, the wild type. Trix that I just mini prepped, no name that I just mini prepped, PAC 18 minus BSA1, and pcDNA minus BSA1 that I prepped. I'm gonna cut with two enzymes. This one's ASE1 and this one's BSA1, high fidelity, with their buffers. So BSA1 works in Cut Smart. I got this from New England Biolabs. And ASE1 works in 3.1, in buffer 3.1. So I'll do a dilution now. I'm not gonna add 17 microliters of DNA. I'm gonna just add 5 microliters of DNA, 12 or let's just say 7 microliters of DNA, 10 microliters water, 2 buffer because it's 10x, and 1 microliter of enzyme. I should go about this, you know, more technically, but what can you do? So 10 microliters of water in each of these tubes. Done. Let's take this into the freezer. These I'll leave at room temperature for now. See, this is my gel compared to the simulation. What I see here is some problems. So this problem I had before, but I didn't know exactly what that was. So if we have a look at the gel, so the first lane here is okay. It migrated exactly like it should. Lane number 5, which is P3X, migrated as it should. Lane number 6, this is the PAC18 plasmid, which is not linearized, so this is the supercoiled form with different plasmid forms, so nicked and linear and circular and so on. The problem is here with these two lanes, because as you can see, I have additional lanes here. So regarding pcDNA minus BSA1, I have 2 additional lanes that should not be there. So this migrates exactly like it should. So this is the linearized form of the plasmid. However, I have these 2 lanes here, which are basically like a bonus. Same thing here with my plasmid, with no name. I have an additional band here. So, as I told you, I had this problem before, and I figured, okay, I know what kit I used for making my mini prep here, and I decided to change the kit. Why? Well, because of this gel right here. Let me show you. These 3 lanes right here, 1, 2, and this one is it's just my no name plasmid cut with ASE1. So I should get 3 bands here, 1, 2, 3, but instead I'm getting 5 bands. So what's the issue with these bands right here that appear between my desired bands? So first of all, I didn't know. I thought, okay, maybe it's some kind of plasmid contamination. Maybe I have 2 plasmids there. Maybe my plasmid did not assemble properly, and additional bands can appear, of course. However, what enlightened me, so to say, was this gel right here. Because I thought, okay, I did 2 different preps and put them on the same gel, digested with ASE1 as I did before. However, you can see here that these bands appear on the right lanes, and on the left lanes there is no band here. So I thought, okay, what's different between these 2 samples and these 2 samples? And it occurred to me that I was using a different kit for prepping. So this is kit number 1 and this is kit number 2. So I thought, okay, maybe my plasmid assembled correctly, and maybe I don't have any plasmid contamination, and maybe it's about star activity. Star activity basically is that my enzymes cut non-specifically in my DNA. So for example, if I incubate with ASE1, as it were, as I did actually, the enzyme ASE1 cuts non-specifically, so it cuts sites that are not the restriction sites of the enzyme, but rather similar sites. So this can occur for different reasons. Too much glycerol in my reaction, too much enzyme to DNA ratio, or some kind of contamination in my prep. Who knows? All of these factors can contribute to star activity. So what I thought, because as you've seen, I got star activity in my prep, so I figured, okay, let me do 2 preps from the same flask again and compare them. So this is exactly what I did here. As you can see, lanes number 1 and 2 right here are made with using mini prep kit 1 with Zippy. Mini prep kit 2 was used to prep the samples in lanes 3 and 4. As you can see, I get here star activity, and here I get no star activity. So this is really helpful and for me, and I'm glad, because this means that my plasmids got assembled correctly. I have in my bacteria the plasmids I want, but sadly, probably is something wrong with the elution buffer in this kit. Maybe, I don't know, the pH is not right. Too high or too low pH can contribute to star activity. Maybe I have some kind of contamination. I have no idea. After measuring this with a nano drop, I found out that my mini prep kit 1 is not as pure as the mini prep I did with kit 2. It wasn't the preps were not good per se, but yeah, this is the problem I got, and how I solved it. So yeah, my plasmids got assembled perfectly. This is some kind of troubleshooting that you're most likely to encounter in your project. So hopefully this has been helpful, and yeah, I'm just glad that that my plasmids got assembled correctly, and now I can move on with other stuff.